Hey folks, and welcome to today's tutorial or today's lesson. Today we are going to be talking about another variety of word problems. This is the fourth and final lesson of our word problem section of the linear systems unit. Today's problems are focusing on problems where you have speed, distance, and time in the question. In the previous problems, we have only been really looking at two factors. So for example, in the previous lesson, we were looking at two solutions that were being mixed together. One of them is like the value, and one of these the amount. Here we have a little bit more information, and these can be somewhat trickier to wrap your head around, only because you need to know how to manipulate the distance time formula, which we're going to be talking about. Let's get started with an example. Sam took a 440-kilometer rugby trip, traveling by bus and train. The bus traveled at 80 kilometers an hour, and the train traveled at 100 kilometers an hour. The whole trip took 5 hours. How far did he travel by bus and by train? Okay, let's start by setting up our let statements, just to remind us what we were looking for in this question. Our question at the end here, how far did he travel by bus and by train, is going to tell us what our let statements need to be. I need to know how far he traveled by bus and how far he traveled by train. So I'm going to let B represent the distance by bus, and I'm going to let T represent the distance by train. Okay, nice and easy. I have now set up my table here where we have the information for the bus trip, the information for the train trip, and the information for the total trip that he has taken. And remember, we are dealing with traveling and distances, speeds, and times. So here we're going to keep track of our 3 bits of information. Let's start by filling in this table with the information that we already know. Well, I just set up some variables here for distance traveled by bus and train. So I can set up that B is the distance traveled by bus and T is the distance traveled by train. We also know that the total distance from the problem is 440 kilometers. We can already tell just by looking at the way this is set up that we are going to have our first equation for our system of equations coming from that first line there, nice and easy. Now we need to figure out our second equation. We have some speeds that were provided, 80 kilometers and 100 kilometers, so let's go ahead and fill those in. The bus was 80 kilometers an hour and the train was 100 kilometers an hour. I don't know how much time he spent on the bus or on the train, because those are both directly linked to the amount of distance traveled, right? The faster you're going, obviously the more distance you're traveling, but it could be proportional, so we got to figure that out. But I do know that his trip in total took 5 hours, so I can fill in 5 hours right there. Okay. Now is when we need to introduce ourselves to our distance time formula, which I have written off to the side here. Distance is equal to the speed times the time, and that makes sense. Distance is equal to speed times time. For example, if I'm traveling at 40 kilometers an hour and I travel for 2 hours, I know that I've traveled 80 kilometers. It's pretty straightforward. This is going to be the baseline formula that we sometimes need to manipulate in order to get the information that we have. Here, I can see that I have the total information, and that's what tells me that I can grab a formula from this first line. I'm also going to need a formula from my last line here, because I don't know what the average speed was of the trip, but I do know that it took 5 hours total. So I'm going to need to fill in these bottom 2 rows for the bus trip and the train trip. I need to know how much time Sam spent on the bus and the train. And that's why on the left here, I've rearranged my distance, speed, time formula to isolate for time. I have said time is then equal to distance divided by speed. Some of you in science may have seen this triangle with a D, an S, and a T. It's okay if you haven't. I'm not going to be introducing that, but for some of you it might be an easy way to remember how to organize your formula. I'm perfectly fine in math just writing it out long like this and rearranging for the variables that you need. It's totally up to you. Okay? In order to find my time, remember I said my time is my distance divided by my speed. So I'm going to do that. Time is b divided by my speed, 80. So the amount of time that I spent is b divided by 80. The amount of time I spent on my train is going to be t divided by 100. T divided by 100. And now we have our two formulas. Okay, formula number one, equation number one, b plus t is equal to 440. Our second equation, not nearly as nice, b over 80 plus t over 100 is equal to 5. Okay, now we can go ahead, we have two equations for our two variables, and now it's just a matter of solving. I'm going to start by manipulating our second equation here just to kind of clear it up. No one ever likes working with fractions, and so we are just going to deal with those right away. I'm going to go the easy and the lazy route out, and I'm just going to multiply everything by our two denominators multiplied together. I'm not going to try to find a common denominator. I'm just going to multiply everything by 8,000. Okay, that's going to give me 100b plus 80t is equal to 40,000. Okay, a pretty giant number. Let's divide everything by 10 just to be easy. And now I can also see that I can divide everything by 2. So I'm going to go 5b plus 4t is equal to 2,000. These steps here aren't technically necessary, but what they're doing is they're making my first equation a lot nicer to work with because now I don't have any fractions. You could immediately start working with your equation if you wanted to in the full fraction form. There's just more room for error, so I would suggest that you do try to manipulate it as much as you can. Okay? Now we have our two equations here. We can solve them either by substitution or by elimination. Let's solve them by elimination, and let's eliminate t. So I'm going to multiply my entire equation. Here, let's multiply it by 4. Okay. That gives me 4b plus 4t is 1,760. We can go ahead and we can subtract these now. I can have 4b plus 4t is 1,760, and 5b plus 4t is 2,000. Subtract. This leaves you with negative b is equal to negative 240, so b is 240. Remember, b is the distance traveled by the bus, and so we know that in total of the 440 kilometer trip, 240 kilometers was spent on the bus. Now I can find t, and I'm going to plug my b into my first formula here. So we just have b plus t is 440. B is 240, so 240 plus t is 440. T is 200. And we can write our therefore statement. Therefore, he traveled 240 kilometers on the bus and 200 kilometers by train. Okay, and there you have it. So that was the first example of using our distance, speed, time table. Let's flip it over here and let's get on to another problem. Alex drove 500 kilometers from Toronto to Ottawa in 6 hours. She drove part of the way at 120 kilometers an hour and the rest at 60 kilometers an hour. How far did she drive at each speed? Just to put a little bit of practicality and reasonableness on this, because Toronto to Ottawa is mostly a highway, she probably drove most of the way at 120 kilometers an hour. And all the residential streets and kind of in and around Toronto and in and around Ottawa, that would be when she was driving slower. Okay, so let's start. Once again, we're looking how far did she drive at each speed. So I'm going to let F represent distance traveled at 120 kilometers an hour, F being fast, and let S represent distance traveled at 60 kilometers an hour. Fast and slow, fast and slow. Okay, we're going to fill this in. I'm going to say distance, speed, time, and here we're going to go fast, and here we're going to go slow, and this is the total trip. Okay, I'm going to start by filling in some information. We know that in total she drove 500 kilometers. So the total distance is 500. We know the total time was 6 hours. So a 6 hours here. We know that the fast speed is 120 kilometers an hour. And we know that the slow speed is 60 kilometers an hour. Okay, I set up my variables for my fast and my slow. Distance for fast is F, distance for slow is S. Okay, we recall that time is equal to distance divided by speed. And so the amount of time that she spent driving fast is F over 120. And the time spent driving slow is S over 60. And now we have our two formulas. Equation number 1, F plus S is 500. F over 120 plus S over 60 is equal to 6. Once again, with my second equation here, I'm going to try to clear the fractions, and I can see that I have a pretty nice common denominator here, or if I multiply everything by 120, that's going to clear my fraction, so I'm going to do that. Times it by 120. Okay, that gives me F plus 2S is equal to 6 times 120, which is 720. Okay. I have two very nice formulas here. I already have an F that has a coefficient of 1 for both of them. So once again, I'm going to use my elimination here. F plus S is 500. F plus 2S is 720. And I'm going to subtract because I'm trying to get rid of my F's. F minus F cancels out. S minus 2S is negative S. 500 minus 720 is negative 220, right? 500 minus 720. Yep, negative 220. So then S is equal to 220. So we know that she drove the slow distance at 200, or she drove 220 kilometers at the slow speed. We know that F plus 220 is equal to 500. So F must be equal to 500 minus 220, which is going to be 280. So the total distance that she traveled moving fast, so moving at 120 kilometers an hour, is 280 kilometers. I can go ahead and I can write my therefore statement. So therefore, she drove 220 kilometers at 60 kilometers an hour and 280 kilometers at 120 kilometers an hour. And that ends that type of problem. So in the previous two examples, we had two situations where we knew the total speed, we know the total time, we knew the total distance, we knew the speeds of the two different parts of the way. In the next two problems that we are going to look at, we're going to consider situations where you have a little bit of a boost, okay? And so what this boost is going to look like, this is the little note at the bottom of my page here, is imagine you are flying in a plane or if you're traveling down a river. When you're flying in a plane, wind can either help you or it can hurt you. Just like when you're traveling in a river and the current can either help you or it can hurt you. When you are traveling with the wind or the current, that means that you're traveling in the same direction as the current. You're moving faster. When you're traveling against the wind or the current, so when you're traveling in the opposite direction, it's slowing you down. And so you are moving slower. In the next two problems that we're going to look at, we need to consider this information in order to help us figure out what the question is asking. Okay? So let's flip it over and let's look at the next example here. Okay, so in our example, the question says, flying into the wind, an airliner takes 4 hours to go 960 kilometers. The same plane flying with the wind only takes 3 hours to make the same trip. Find the speed of the wind and the speed of the plane. Okay, so two pieces of information here. Flying into the wind, so going against the wind, it takes 4 hours, but flying with the wind, it takes 3 hours. It's a little bit easier to go the same trip. Let's start off with writing some of our let statements here. Again, I'm finding my let statements right from the last line of the question. I need the speed of the wind, the speed of the plane. So I'm going to let W represent the speed of the wind. I'm also going to let P represent the speed of the plane. Okay, we don't know what either of those things are though. We just know the distance and the total time that it has taken. We can also know, we're going to say therefore then, when we are flying the plane and the wind is on our side, P plus W is the speed of the plane with the wind. That makes sense, right? With the wind means it's happening, like they're happening together. So I can add those two values. Likewise, I can also say then the speed of the plane minus the wind is the speed of my plane against the wind. Because the wind is hurting me, it's reducing my speed here. Okay? When it's a plus, you think that the wind is helping you. It's moving you along faster. Whereas the minus, it's slowing you down. You're going against the wind. Okay? Let's start setting up our table here. We're going to do it the exact same way where I have distance, speed, and the total amount of time. Here, I have two different situations. I'm going with the wind, and I'm going against. We know that regardless of how the wind is facing that day, the distance that I am traveling is 960 kilometers. So I can fill that in. 960 kilometers. I know that the speed, we just set this up, the speed going with the wind is P plus W. And the speed going against the wind is P minus W. I also have been provided in the question the amount of time that it takes to travel. We said that it takes 3 hours to go with the wind, and it takes 4 hours to go against the wind. Now is when that distance, speed, time formula comes into play. Remember that distance is equal to speed times time. That means that I can set up my two equations the following way. I can say that with the wind, my equation, distance, 960, is speed, P plus W, times time. I also know that against the wind, I can do the exact same thing. I can say that 960 is equal to P minus W times 4. Now we have it. Two equations, two variables. I'm going to expand both of these equations to get rid of my brackets. This is going to give me 960 is 3P plus 3W, and 960 is equal to 4P minus 4W. Once again, it's up to you how you would like to proceed in terms of isolating your variables. You can use substitution or you can use elimination, either or. I think I'm going to use, let's do elimination in this case because it looks pretty easy. I'm going to multiply my top equation by 4 and my bottom equation by 3. Okay? This is going to give me, so 960 times 4 is 3,840 is 12P plus 12W. And then 960 times 3 is 2,880 is 12P minus 12W. I'm going to add, because I already have a variable that has opposite signs, 3,840 plus 2,880 gives me 6,720 is equal to 24P. 12 plus negative 12 cancels out. So then I divide both sides by 24. Okay, that is equal to 280 is equal to P. Remember, P is the speed of the plane. We can then isolate and we can solve for W, the speed of the wind. Okay, so I'm going to go and I'm just going to plop this information into my first equation. I'm going to do that over here. Remember, 960 is equal to 3 times 280 plus 3W. So then 960 is equal to 840 plus 3W. I then subtract 840 from both sides. That gives me 120 is equal to 3W. And when I divide both sides by 3, I get that 40 is equal to W. Remember, W is the wind speed. So in total, we have our final conclusion here. We can say, therefore, the plane is traveling at 280 kilometers an hour, and the wind speed is 40 kilometers an hour. Okay, not so bad, not so bad. Let's do one final example with a very similar setup, except instead of wind, we're talking about current. We're talking about a boat. A riverboat took 2 hours to travel 24 kilometers downriver with the current. Okay, downriver always means with the current. And 3 hours to make the return trip. Find the speed of the boat and the current. Okay, we know we can find right away our let statements. Let's write those out so we know that we are looking for the speed of the boat. So I'm going to let B represent the speed of the boat, and let C represent the speed of the current. Just like we did in our last equation, I then know that B plus C is when the boat, the speed of the boat with the current, and B minus C is the speed of my boat against the current. Remember, with the current means that the current is helping you, it's speeding you up. Whereas C being subtracted means that the current is slowing you down because you're flowing against it, you're moving away from it. Let's set up our table here. We have distance, speed, time, and we have with and against. The total distance traveled in both of these situations was 24 kilometers because we are going down the river and then we are coming back. So the distance in both cases is 24 kilometers. We are looking for the speed. So remember, the speed with is B plus C, whereas the speed of the boat against is B minus C. And the total time it took, so it took 2 hours to travel with the current and 3 hours to travel against the current. We recall that our formula is distance is equal to speed times time. And so my formula with the current is 24 is equal to B plus C times 2. And the formula going against the current is 24 is equal to B minus C times 3. I'm going to expand both of these to remove the brackets. 24 is equal to 2B plus 2C, and 24 is equal to 3B minus 3C. Okay, not so bad. Once again, I'm going to solve these by elimination. No, you know what? I'm going to do substitution. Why not? I'm going to isolate B in my first formula. So 24 is 2B plus 2C. Let's isolate B. I'm first going to move my 2C over. And then I'm going to divide everything by 2. I can then substitute my 12 minus C in for B up here. Expand. I'm going to move my 36 over. That gives me negative 12. And I combine these like terms to be negative 6. C. Divide both sides by negative 6. I get 2 is equal to C. It's moving at 2 kilometers an hour. I then substitute this information back into my formula for B. B is equal to 10. So I can write my therefore statement. Therefore, the boat is moving at 10 kilometers an hour and the current is moving at 2 kilometers an hour. And that's that.